Hello, everyone. I'm Chris. Todd, if you go to the next slide, we're going to give everyone a few minutes to filter in. If you're joining us, go ahead and set the chat to everyone. Sometimes Zoom will default it to panelists. Just make sure you're talking to everyone. Once you made sure you're talking to everyone, let us know where you're joining us from. And then, is there anything you wish AI could do for you? It can be a practical wish, or it can be a fantastical wish. Whichever. Both are acceptable. Couple California, Maine, New Jersey. I wish AI could write my evaluation goals. That's good. I'm not sure what I want AI to do. I'm not either. Can we trust it yet? I'm not sure. Oregon, California, Arizona. AI can scoop my cat litters. That's an amazing thing. I don't know why we don't have those robots yet. Someone needs to get on it. If you're joining us, we're going to give about 30 more seconds for people to join. Go ahead and say where you're joining us from. And our theme is AI. What do you want AI to do for you? I think scooping cat litters might be the winner for now. Generatively draw hands, fingers, and mouths better. It's getting better. We're not there yet. Fold laundry. Woo, that's a good one, Kelly. It could, but it won't write their entire essay. That's great. All right, thanks everyone. These are really good ideas. My name's Chris. Just a little bit of housekeeping. It looks like people are setting their chat to everyone. Make sure that you're talking to all of us, not just hosts and panelists, so that everyone can see where you're joining us from and what you want AI to do for you, like fix the world. This is going to be about 35 minutes, and then we'll have a Q&A at the end. Make sure that you ask questions through that Q&A feature. We've got some great moderators on that are helping us out. It helps us keep track of your questions, make sure that we're answering them. So please use that. And then don't worry, this will be recorded and it will be sent out after the webinar. So if this weekend you want to watch this again because it's so great and there's amazing information, you will be able to do that. All right, next slide, Todd. Okay, quick agenda. Who are we? I'm Chris. Todd is here too. We'll tell you a little bit about ourselves. Then we're going to talk about Hour of Code, kind of generally about what AI is and what it looks like in classrooms. And then we'll get a little more specific and walk through some activities. And then just share some general things here at Sphero that we're working on that are new or up and coming that we're excited to share with you. Then we'll have a Q&A, and then at the end, we end with a giveaway. So we'll randomly select someone from the chat to get a Bolt, a Rover Plus, Indy, or Mini. So stick around for that. All right, let's go ahead and get started. Todd, tell us.
All right. Thanks, Chris. So my name's Todd. I was a classroom teacher, 3rd, 4th, and 5th grade for about 10 years. And after that time, I entered the world of EdTech. I've been with Sphero for about 3 years. I spend my days working on curriculum and lessons to support you all using our robots in the classroom. So I love hearing from you about what's working, what's challenging, and what we can do to help.
Great. I'm Chris. I'm also on the content team. I used to teach kindergarten and 5th grade and was a literacy coach in Chicago. For the last decade, I've been working on curriculum development and assessment, and I'm really happy to be here today. So let's go ahead and get started. Artificial intelligence. So why are we talking about AI today? Well, it's the Hour of Code theme for this year. They selected it. I don't know if you've noticed, but it's very popular these days, especially since ChatGPT came out about a year ago now. And if you haven't already, they have some really excellent videos. If you have questions, if you're like, I'm not sure how this works. What is a large language model? I'm not sure. They have a series of videos that are really, really good. So I highly recommend you checking out their website and clicking on those videos. They're like 2.5 to 4 minutes long. So they're really bite-sized. They're really well done. And they have people from industry, from diverse roles that are explaining really complex things in a way that makes sense, not just for our students, but for us too. So plug for them. All right, next. Okay, so how do we talk about AI? Like I said, it's become really, really, really popular. And anytime something sort of comes into pop culture or the media or social media, sometimes nuances are lost a little bit. And we're used to this in education. If you remember, just a quick example, in 2016, Angela Duckworth wrote the book Grit, and it got really popular really fast, and people were trying to apply it in education. And there were at least like two sort of misconceptions that came out of that. One was grit means you just work really hard and you never give up. But in the book, there are examples of Duckworth actually giving up on things that she wasn't passionate about. So grit included, her definition of it was the passion to persevere through long-term, working towards long-term goals. So that passion piece, you have to be excited about it to get through the hard parts of learning something new. And that was kind of lost in this larger discussion. The other thing was there was a self-assessment in the book, and people were like, oh, there's a test. Let's test our students on grit. We want them to be gritty. We will tie that to teacher evaluations, and we'll make sure that our kids are getting gritty. But that's not what the self-assessment was meant to do in the book. And Duckworth herself was like, no, 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 please don't do that. That self-assessment is for reflection, to think about where are you gritty, where can you improve. Sometimes we're gritty in certain contexts and not in others, and it shouldn't be used to judge teachers or students. So there are things that when they become really popular, some of the nuance is lost. And we're seeing that a little bit with AI. It's really popular. A lot of people are talking about it. Sometimes those conversations are informed by science and history and mathematics. Sometimes they're more informed by movies with Terminators in them. So I think it's important to think about what is artificial intelligence, and I'm going to break that into two different spheres here. One is the technical sphere. So you can get into what is the history of machine learning or AI. We like to think about it as like being this brand new technology, but the idea of creating a neural network based on our brain was started in the 1940s. That's when the first idea was proposed. It's a mathematical model that sort of represents what our brain does. And now with the computational power we have and the data we have, we're able to do it in very sort of impressive and sometimes eerie ways. But it has a long history in statistics and mathematics. So I think it's really important to think about when we're talking about this with students, this just doesn't come out of anywhere. So there are other things we can talk about. Training. There's training on data sets. There are human trainers that say like, this is good, this is bad, and then the model sort of auto-corrects itself. Then we look at things we use every single day. You type in a phone or on your computer. It tells you what your next word might be. It tells you, hey, you spelled this word incorrectly. It might translate from Spanish to English or English to Spanish. We have speakers that listen to us and will do things for us, which is kind of crazy. Spam filters in your email inbox, talking about old technology that's based on Bayesian statistics from the 18th century. Only now do we have a sort of use case in the computational power to put it to good use. And then recommendation systems. You bought something, here's something else you might like to buy. You watched something, here's something else you might like to watch. So those are sort of the technical things and conversations you can have with your students. And then there's the maybe more challenging conversations you can have or that are philosophical. So self-driving cars are really popular. There's the technical sort of hurdles that we have to get through, like how does a car identify a red light? It stops. How does it identify pedestrians? Then there's the ethical questions around like, if there's an accident, who does the car try to protect? Is it the passengers and the driver? I guess not a driver in that case. Is it the people around the vehicle? Is it a school bus? There's a lot of really complex questions and discussions you can have with your students that can get really deep. Depends on the context of your classroom on how deep you want to go there, but it might turn out these ethical questions are maybe harder to solve than the technical questions, but it's a really good place to start and have those conversations. Ownership. So if I type something into a chatbot and it puts something out, there's an output. Is that mine? Is it the chatbot's? Here we have Dali's interpretation of a robot playing chess by Matisse. who gets credit for this? The person who typed it in, the model that made it? Should we give credit or compensation to Matisse? There's a lot of really hard questions around who is the owner of these things. Creativity. Creativity is kind of hard to define. If you have ask artists who are, poets, or they're drawing pictures, murals, writing songs. Creativity is really hard to define. Can a robot or a model or a program be creative? I'm not sure. That's a really good discussion to have with your students. We talk about these models as being black boxes. They take a bunch of information, they do something with it, and there is an output. But how different is that from us? We have our lived experience. We have our own data that we were trained on. There's like billions and billions of things that we have experienced up until this point in our life. We do something with that, and there's an output. What's the difference between my creativity and a model's creativity? I don't know. And then bias. Bias is another place there's a really difficult conversation around. A model is written by humans. Humans are biased. It's trained on data that's created by humans. So if that data or those data are biased, the output probably will be as well. So how do we deal with that? How do we identify it? Is it creating another model that's adversarial and it looks for bias in this model? There's a lot of really crazy things that you can get into there. And then equity. So we have companies worth billions of dollars. They're paying their AI trainers $2 an hour to train their model that they will make lots of money off of. Is that equity? That's a really, really good conversation to have. So that's a very broad overview of the different things you can talk about and discuss when you're talking about AI with your students. And you might notice that I didn't talk about one of the big topics right now, which is, should AI be used by your students in the classroom? And that's a conversation that you can have in your districts, in your schools, with your parents. However, I think the important process here is AI is going to be a part of your student's life, probably indefinitely. So what can we do now to prepare them for what this looks like in the future? So talking about the technical aspects, learning what training is really important. Having those conversations around ethics and equity and ownership are also really important, because they're going to be dealing with this for the rest of their lives. How can we set them up to deal with these really tough questions? So there's my spiel on AI in general. If we go to the next slide, Todd, what are we doing with this? So what is our focus? So we have a few lessons here. Todd is going to do a deep dive into our Rover Plus activity, and then I'm going to look a little bit at our Indie activity. And the focus of them is not so much, we're not building neural networks with our block coding. We're talking about these concepts. So Rover Plus looks at if-then conditionals. If Rover encounters something, it does this. We also talk about levels of automation. In cars, parts are automated. Like, it rains on your windshield wipers turn on automatically. That's automated. So Todd will get into that in a little bit. Then I'm going to talk a little bit about Indie and training. So Indie is a car, it can drive. We're going to make a connection to autonomous driving in cars, and then talk about what do those cars need to go through this training to get better at driving in their environment, and then have students do a little bit of training on their own. And then Bolt, we have a lesson with ChatGPT, and don't worry, we're not having students kind of go wild and input things into ChatGPT. Todd created this. It's a really great lesson. He is showing the output from asking, hey, can you write a program for Bolt that does this? It made a program. It looks really cool. It doesn't quite work. So we go into a little bit around what are hallucinations? Even if something says something very confidently, it's not always correct. So you need a certain level of background knowledge in order to be like, hey, hold up, let's correct that. So we'll get into some of these. And then next up, Todd is going to show us a little bit about how to find these activities on Power of Code.
Yeah, thanks, Chris. So to find the Hour of Code activities, you can find them on our website, but you can also find them on code.org's Hour of Code website. So I'm just going to switch over to that tab. And here is their lessons or activities page. If you scroll down on the left-hand side, you can filter by who created the lesson. So if I scroll all the way down here, I can select Sphero. And now you're going to get a list of all the activities we've submitted to Hour of Code over the past, I don't know, 5+ years. And then on the left-hand side, if you want to see this year's artificial intelligence activities, under topics, select AI, and you'll see 4 activities here. There's actually a 5th one that we've written. It is for little bits. So to find that one, you've got to go into created by and select little bits by Sphero. And now you'll see that activity. You can also find these activities with the exception of the indie one, which we'll share later, but you can find all of these on edu.sphero.com. So let's dig into these activities because like as Chris just said, like it's these big discussions that are happening across our society about the role of artificial intelligence in our lives are huge, right? But kids can't engage in those discussions, or at least not very productively until they have kind of that foundational knowledge, right? And I really see that as the role of schools and educators in talking to kids about these technologies that are becoming an increasing part of their lives. And I'm seeing lots of things in the chat right now of other resources people are sharing that are good launch points for discussions, and please keep sharing those. So the first activity we wanted to talk about was AI with Rover Plus and about autonomous vehicles. And so this one, as Chris mentioned, is not, kids are not engaging in artificial intelligence. They are programming Rover to drive autonomously without human input, but they're doing that entirely in a rules-based system. But they are starting to talk about and learn the terminology to talk about autonomous features in cars. Again, we will post these in the chat, but if you were to go onto edu.sphero.com, you can find this lesson plan. And attached to this lesson plan, there's also an educator guide that goes along with it, where we have a lot of information to support you. One thing I want to draw attention to at the very top of activities, this has been a feature for about 4 or 5 months now. But if you take this thing called an activity code, this one is 74228, and then you have students open the app and click the little activity button and enter 74228, they will jump straight to this activity without having to sign in. So it's a great way to share these activities with students. Okay, so let's jump in. This activity is really framed around this chart. This chart comes from the SAE International, and it's the levels of driving automation. There are actually 6 levels. With students, we mainly talk about blue versus green. All the levels 0 through 2 are really driver support features. So a good example here would be the ability to emergency braking, right? If something is immediately in front of the car can come to a stop and keep passengers safe. And then in the green categories, 3 through 5, these get into more fully autonomous features that are automated driving features. The car is actually driving itself. Some of these are much more limited than others, right? The ability to stay in your lane and drive on a freeway is obviously very different from being a fully autonomous taxi. So the first step here is kids program Rover with one simple block, dragging the stop block to the on color block to stop when it sees yellow. So this is an example of that driver support feature. Again, remember, this is a rules-based system. It's only stopping when it's seeing yellow because we've told it to. The next step is we want to tell Rover to stop when it sees the yellow. And then we also wanted to tell it to take a right turn. And that works pretty well, except that this Rover can only take right turns. So it gets in a little bit of trouble. Again, we're just giving a simple if then else statement. We have taken a lot of the programming focus off, or the programming complexity off of this activity for students. You can see here we're embedding a function called right turn. If you have new students, maybe you don't dig into what's in that function. If your students have been programming with Rover Plus or other robots for a while, they can by all means go over to that right turn function and look how we've defined it and dig into some of that. And then finally, the car will make it down this path by first taking a right turn. And then if there's still something blocking that other way, it will turn all the way around and go left. So it checks that path to the left and it makes it out. So we've talked, I know, multiple times that this is not AI, but it is a launching point to talking to kids about how AI is involved in autonomous cars on the road today, right? Like imagine if the sensors on this car were able to detect yellow and then gather data and send that data to other cars and start to create a model of other things that are similar to yellow that are also dangerous that might want to cause them to stop. Imagine also if this car was sending data back and gathering data and able to transmit that data to other cars that might be driving down this road so that a car wouldn't even need to use its sensors to navigate this path. It could do it based on the information of others. So this is a very simple activity, but it starts to unlock those greater complexities. Again, here we've also got a bunch of discussion questions that are just great to talk about with students, right? What part you can talk about the lower level ones, such as how is Rover autonomous in that example? How is it not autonomous? You could talk about how kids might feel about it. Would you want to be in a driverless car? Why or why not? And then you can start to get into some of those ethical questions that Chris already mentioned earlier. Like, are we comfortable with artificial intelligence starting to make decisions that might not have a clear right or wrong answer? And again, rules and regulation are going to be huge, right? And so start to bringing up some of this. All right. And now we're going to go backwards from kind of a middle school lesson down towards talking about some of these same topics with much younger students.
Yeah. So Indy, if you're unfamiliar with Indy, it's a little robot. It has a color sensor on the bottom, and it goes over colors, and there is a clear input, the color blue, the color green, the color purple, and a clear output. So Indy always starts on green. Green means go. When it senses blue with a tile, it comes with tiles, it will make a 90-degree right-hand turn. So Indy can kind of drive autonomously already, but it's still within, Todd mentioned this rule-based system of if Rover plus sees yellow, do this. Indy is doing the same thing. It's abstracted a little bit. If Indy sees green, do this. Drive straight forward. Sometimes it makes it faster. So Indy's already kind of doing this, but the conversation that we're focused on here is what are self-driving cars and how do they learn how to drive? So the focus is on training. And this is important. There are suggested conversation or discussion questions around like athletes, what do they do to get better? There's training, right? You need to do certain things to get better at something. Cars are the same way, and the models that will be behind these self-driving cars are similar too. So what students are going to do is they will have a course. They will use the app to drive it themselves. And if it's their first time driving, they might need a little bit of practice. They might need training themselves to figure out, okay, how do I drive Indy? How do I make it go down this specific path? And then they'll be able to have Indy drive that course independently and have that discussion between like, what was easier, you driving or Indy driving? Did you require any training? What was the training that Indy went through? And we don't really see that with Indy. So now we're going to go into what training with Indy might look like. So these two examples on the bottom of the screen, if you know Indy colors, you might be like, hey, wait a second, purple doesn't make Indy turn right or turn left 90 degrees. Purple is the best color. Purple makes Indy celebrate. But now students are going to have to train Indy to do something different on purple. So they're going to have to use our app. They will use these block codes and change what Indy does when it sees purple. So instead of celebrating, Indy is going to need to make a 90-degree left-hand turn. So they'll train Indy how to do that. Once it gets to pink, you might know pink usually is a left-hand 90-degree turn. Now we want to make a right-hand 90-degree turn. So students are going to then train Indy how to react to pink. So there will be a few of these examples that kind of increase in complexity. And each time students will have this opportunity to train and retrain Indy to do these things. And then have those conversations around what does training look like for real cars. You can kind of you can go down that rabbit hole if you want, or you can keep it really self-contained in like, hey, Indy knew how to drive, you trained it to drive a different way, and you were able to do that. And this is the way that self-driving cars are going to improve and work as well. They're going to need feedback from humans, and they're also going to need feedback from their environment, like these color tiles. So this should be a really fun and exciting experiment and experience for kids, and kind of get them, in the pre-K to 2 grade level to think about what it would be like to have a car that drives around with no driver. So very excited about the Indy thing. All right, Todd, you're going to tell us a little bit about collections. We're moving on to some of the new things that we're going to share with y'all.
Yeah. Yeah. So that was just we kind of dove into 2 out of the 5 activities we have now featured on code.org's Hour of Code website. And so we'd love your feedback if you get a chance to do them this week during Hour of Code or next week, anytime. We'd love to hear how it goes for you. We have some new things to talk about and to share at Sphero that mainly we want to share them so that you make use of them. And one of them is collections. And for this, I'm actually just going to pop over to the edu.sphero.com and we can look at this and what it looks like in real life, not a screenshot. If you go to the activities tab, again, this is our website for teachers for them to get ideas. Just about a month ago, I guess it was beginning of November, if you were to go to this page, you would have gotten a page that looks like this. And you would have seen a page like this for a while ahead of this too. We're just getting a full list of our activities. And what we notice is that teachers were always seeing these same 20 activities because they're on the first page, but they weren't seeing the rest of our 280 activities and so what we wanted to do is give teachers a tool for helping to find those. And so we now have what's called activity collections. And we've taken some of our most popular activities or activities that we think are the best, and we've put them into groups. And so you can filter this group, let's say by Bolt, and then by middle school, and you can find groups of activities that are relevant to your students. So for example, here's the cybersecurity collection. We published these activities about a year and a half, 2 years ago, and gradually they've gotten pushed down that list. So here's an easy way to get back to that, to these lessons. At the top of the collection, there's a link, view educational standards for these activities. And for collections with activities that are aligned to standards, you can always click on these and see all the standards in one place. That's another nice little feature. And then from here, it's a much easier way for you to go in and find these activities. Another one to focus on really quickly, just because it's new, is we were playing with some Bolt challenge cards this fall. And these are all really, really quick, 15 to 30-minute activities where we give kids a program to build. And then they do some problem solving and some playing, and it's a great way to kind of tour all the blocks or a lot of the blocks on the block canvas. And you can find these right here under the Bolt challenge cards activities. Finally, we wanted to share off a brand new collection for elementary math. And this is a little different from other activities we've written because these activities focus less on the programming and more on the math standard. They're very targeted. Each one is for 3rd, 4th, or 5th grade. We're not trying to do too much with any one of them. These are not the activities to introduce a math topics to your students, but they are great activities for you to use to kind of reinforce those math topics with students. So for example, this decimal shake one is an activity that is focused on a grade 5 math standard about adding and subtracting decimals. And so what kids do is they shake Bolt, and Bolt will generate a, a decimal number between 0 and 1. And then they play a game versus a friend where they shake Bolt a certain number of times with the goal of getting as close to 1 without going over. And it's just a fun way to use our product to reinforce that math standard. Couple things to point out at the top. Here's that activity code. Just give that activity code to your kids, show them where to plug it in, and they'll be using it. There is an educator guide for this one. Looks like it's a Google Doc or a PDF with tons of information for you about supporting this activity. And then there's this little button here, fill out the short survey. Again, we'd love feedback. If you don't fill out the survey, send us an email. Just anything you do when you use an activity and have feedback for us, please don't hesitate to pass it on. I think those are the 2 things I wanted to share, and Chris has got one more.
2 more, actually.
2 more. Sorry.
The next one is Power Up Program. So this launches today. We're very excited about this. This is brand new. We're partnering with CS for All to create a program that loans out Bolt Power Packs. So what we're going to be doing is working with schools and organizations that typically work with underserved communities that might not have access to our robots. These can be like maybe your 4th grade and 5th grade team in an elementary school. It might look like a tech team for 6th through 8th grade. We're also having loan periods over the summer, so it might be a summer school option. So there's lots of different organizations or schools that we will work with as long as you're in the United States. But what we're going to do is for 6 weeks, we're going to send you out a Bolt Power Pack, which includes 15 bolts, a great charging case, and some other things. We will work with you. We'll meet with you, kind of go over like, this is how you use it, give you some lesson ideas, be in contact throughout the loan period, and then follow up at the end and say like, hey, did this work well? What can we do to improve? And then ship it off to our next recipient. So we're really excited about this. It's brand new. The loan application process just opens today and will be open until January 14th. And then we'll let you know by the end of January. So if you're interested, or if you know someone who maybe wants to use our products, wants to use Bolt, is interested in incorporating block coding or computer science or cybersecurity into their curriculum, but just doesn't know how to do it or doesn't have the resources to do it, encourage them to apply or apply yourself. And I think this will be a really fun program, getting Bolts in the hands of more students over the course of next year. So really excited about that. Check out the website, sphero.cc /Sphero Pup. It's a great acronym, PUP program. And I'm excited to see our applications come in. We go to the next slide. So this is not new yet, but it will be new in 2024. If you were here for our Indie Literacy webinar, I already sneak peeked this a little bit after Claire talked about orthographic mapping and what Indie can do in your literacy block. But what we're going to do now is we've had code mats for Bolt. You might have played golf or going around the city in Bolt. Now we're going to have a code mat for Indie. And there's going to be 2 sides. One side is a grid like this. If you're a teacher that uses Indie a lot, you might have used painter tape to make grids on your floor to make sure that kids are lining up the tiles correctly. This will kind of make that a lot easier for you. And then the code mat itself is coming with a bunch of cards. Those cards are going to have lowercase and uppercase letters, words, and images. The idea being, if you are a pre-K through 2 teacher and you want to teach, say, letter identification, I was a former kindergarten teacher, so I want to teach, I want kids matching uppercase letters with lowercase letters. I can put, ABC capital on one side, ABC lowercase on the other side, and then have students program Indie to match the capital C with the lowercase c. Maybe then later in the year, I'm moving on to word formation. I give them the letters CAT, make the word cat. They spell it C-A-T. They program Indie to read the word. They make the sounds at, blend them together, cat. And then they make the word cat. And then we can go into sentence formation, maybe with your second graders or your high flyers in kindergarten of, I ran to the library, make that sentence, put a period at the end, program Indy to read the sentence, and then you read as Indy travels below your sentence. And Claire's webinar, and she also wrote a blog post for us that was really great. The cards themselves and this code map will make doing some of the things that she recommended in your literacy classroom during your literacy block a lot easier. On the flip side, this is just a little snippet of it because we're still working on prototypes right now, but it's going to be Indieland. And the idea being there are going to be different locations in Indieland. Each of them is going to be associated with a specific objective. So I'm a teacher. My objective, it's the beginning of the week. We're going to do a read aloud and identify vocabulary words in the book. I am going to do the read aloud. Students can program Indy to drive to the vocabulary volcano. We will identify those vocabulary words, maybe use context to help come up with some definitions, and then have a rich discussion around what vocabulary, what the words mean, what we're going to be doing over the course of the week. There's also the retelling roller coaster. So I read a story. My objective is I want my kids to retell the beginning, middle, and end of a story with key details. Program Indy to drive to the retelling roller coaster and then have that discussion. What happened at the beginning? What happened at the middle? What happened at the end? So just a really fun way to incorporate Indy into your literacy block. We're really excited about it, and that will be coming in 2024. All right, I think that's everything we have that's brand new. Now it's time for some Q&A. I know that we had Paul. Your question was, what are some recommended approaches for discussing the touchy subject of ethics, like copyright law, accessibility, inclusion in AI? And I think that's a really good question. I'm not sure I have a really good answer for it. I think it really depends on where you are with your students, what grade level, the sort of personal connections you have with them. But I do think that you can have sort of broad discussions around, there was a writer's strike recently. Those writers were worried about AI writing scripts for television. What does that mean? So you can have discussions or debates around like, hey, AI should be used to write scripts. Maybe it shouldn't. Why shouldn't it? How are companies going to make sure that their AI isn't used or that people are still getting credit? What if those writers use AI? Is that allowed? There are a lot of like really sticky questions. And this is why, Paul, it's a good question that I don't have a very good answer to, because I think we're all still figuring it out. Although, I said neural nets go back to the 1940s, this stuff is very, very brand new. So I think, at least in its ubiquity and the ability of chat bots to respond so eloquently to questions, not always eloquently. So I think having those discussions and then just being like, I'm curious and I don't have the answer for this, like modeling that curiosity and showing your students that you don't really know. And people much smarter than myself don't have answers for that either. So just trying to struggle through those conversations and maybe using real life examples and maybe having students make pros and cons list of like, hey, this is a good thing about writers using ChatGPT to generate scripts. These are maybe some bad things. Todd, do you have anything to add to that?
Yeah, I would just add on that sometimes it's nice to not make it so personal, right? One thing I like about our robots is that they kind of allow kids to externalize some of these questions into lighter or more or not very realistic situations. So discussing features on an autonomous rover car might be or like the ethical considerations of who has access to an autonomous vehicle with autonomous features versus who doesn't have access. Like that might be easier to talk about in the context of a robot than real life situations. I also wouldn't hesitate to look on code.org's resource list, and also in the chat much earlier I saw someone posted the link to teachai.org. They've got a bunch of great resources as well. It looks like another question about grade levels for activities and our robots. Generally speaking, the Indy activities are for our youngest learners, K2, although in the chat, I'm seeing a lot of people using it for grades 3 through 5, and that's definitely applicable. Bolt here with the chat GPT, we've labeled that activity as a middle school activity just because it's a little bit more complex and ask kids to think about chat GPT. And then the Rover ones too are also labeled as middle school, but can extend up through high school.
Great. Are there any other questions that we can do our best to answer? Otherwise, we'll move on to the giveaway. All right. Okay, so our winner for today is Kelly Sessoms. Hopefully I'm pronouncing that correctly. Someone from our team will reach out to you, Kelly. Congratulations. You can choose Rover Plus, Bolt, Indy, or Mini. Very excited. Thanks everyone for participating. These were really, really good questions and really good discussions that we're going to have in the coming years around what does AI look like, how does it impact our lives, and how do we have these discussions with students? And we'll be learning from you as we do that. Todd, if you go to the next slide, we have all of our socials. If you want to reach out to us, again, we'll have a follow-up email. This will be sent out. It was recorded, and your PD certificate will also be sent, and Kelly will also reach out to you. So thanks again, everyone. We really appreciate your time, and hopefully you learned something. All right. Have a good day, everyone.
Thank you. Bye.